In this lecture, I'm going to be discussing quantitative data analysis, the types of statistical methods and analysis that are used to analyze many types of social science data, including data collected from surveys and common assessments conducted by the government like the census. During the lecture, I'll introduce you to a few statistical concepts, including frequencies, cross-tabulations, and measures of central tendency like the mean, median, and mode. I'll review tools that you can use to conduct statistical analysis, specifically different types of software for doing statistics. And finally, I'll conclude by reviewing some simple data analysis, examples of data analyses. What is data? Data refers to the values of quantitative and qualitative variables that are observed by participants in your research study. In its simplest form, an example of a data set might look like this. So what does data look like? This is a data set that contains two variables, a qualitative variable and a quantitative variable. A qualitative variable is an individual's name, and names, as we discussed in the levels of measurement lecture, a variable like name cannot be ordered or added or subtracted. It's a nominal category, and it's qualitative. In contrast, a variable like age is numerical, has a fixed 0 point, can be added and subtracted, multiplied and divided. So this is a very simple data set. Oftentimes data does not look like this. It might look quite involved. For instance, this is data obtained from the US Census, has populations of different zip codes within Massachusetts, and associated demographic characteristics like median household income and population density. Referring to quantitative data analysis is the process of presenting and interpreting numerical data using statistical techniques. So quantitative data analysis is the process by which you take data similar to that I presented to you in the previous slide, and you use statistics to make sense and make sense of, find patterns in variables and assess the relationship between different variables. Statistics are a scientific discipline that's focused on the analysis, interpretation, and presentation of numerical data. So quantitative data analysis employs statistics to make sense of data. Many scientists distinguish between primary and secondary data analysis. Primary data analysis refers to analyses of data that you collected on your own behalf, and this is often referred to as primary research or primary data analysis, and it's analysis of data that you, the researcher, collects from people. For instance, you might administer a survey to a group of people. That would be an example of primary data analysis. Secondary data analysis refers to analyses of data that were collected for a different purpose. For instance, the US Census is conducted by the government to count the population of different communities around the US. However, census results can be used by researchers to understand how demographic characteristics influence various social phenomena. When researchers use data from the census, that's a prime example of secondary data analysis, because the census was not collected by the researcher who is using it in their research. Well, where exactly can you obtain data? Data is becoming more easily available on the internet, and These are just a few places where you can obtain data, including the New York City recently made available a number of data sets on its New York City Open Data website. The ICPSR consortium is a repository of social data sets from social science research studies that's maintained by the University of Michigan. Many of the data sets that are accessible through ICPSR are publicly available and can be easily downloaded. The General Social Survey is an annual survey that's conducted by the American Sociological Association to assess attitudes and behaviors among a representative sample of Americans. Finally, Open New York is a collection of data sets that were made available by the New York State government. There are various tools that you can use to conduct data analysis. Some of the programs, the software that you can use to conduct data analysis include Stata, SPSS, SAS, and R. R is distinct from the three other software in that it is open source and it's freely available for anybody to download at no cost to the user. The software is maintained by a community of academics and volunteers who submit updates and packages to the software. So it has a bit more of a learning curve than some of these other software packages, but it's a very powerful statistics package. In terms of the types of statistical analysis that you can conduct, descriptive statistics are those that are used to describe the distribution and relationship among variables in your study. Some of these descriptive statistics we've discussed in lectures. For instance, cross-tabulations allow you to view and test for relationships between two variables. In this cross-tabulation, we're looking at the relationship between attitudes about gun laws and gender. And this cross-tabulation suggests that men are much more likely than women to oppose gun laws. For instance, about 30.6% of men oppose gun laws compared to only 17% of women. It allows you to identify a relationship between these two. A frequency distribution shows the frequency of different values across a variable. The frequency distribution on this slide shows the distribution of age for a study of 1,324 people. It allows you to see how many people fall into different age categories, values. Other descriptive statistics that are commonly used include measures of central tendency. Measures of central tendency indicate the values around which a variable tends to center. What is the center point on a variable, on a numerical variable? There are three measures of central tendency, and they include the mean, median, and mode. We'll talk about each of them. The mean is the simple arithmetic average for a set of values. The mean is the sum of all values divided by the number of values. And I'll walk you through an example of mean. In this example, we've collected information about how many cups of coffee different individuals drank each day. Person 1 drank 2 cups of coffee each day. Person 2 drinks no coffee. Person 3 drinks 1 cup of coffee per day. Person 4 drinks 3 cups. Person 5 drinks 8 cups. And person 6 and 7 drink 2 cups. So how do we make sense of this data? In this case, we're going to use measures of central tendency to see if we can identify the center point within these values on this variable, cups of coffee. So what is the mean value for cups of coffee? To calculate the mean value for cups of coffee, we'll add each of the values for the cups of coffee variable and divide it by the total number of values. And that was 7. There were 7 values. The average, the mean of these 7 values was 2.57. That means the average number of cups of coffee drank by persons in the sample was 2.57. About 2.5 cups of coffee. Sometimes it's important to be cautious when interpreting the mean, because sometimes a mean value can be misleading. In this distribution of salaries among a group of staff in an office, you can see that many people in the office earn between $15,000 and $18,000. However, there are 2 staff in the office that earn $90,000 and $95,000 per year. The mean of these 10 values is $31,000. And you can guess that that mean value is not quite representative of kind of the real average or the real attendance center value within that population. So it's the mean when there are values that are exceptionally high within a sample or exceptionally low, they can skew the average value. And so in this case, the 2 values of 90 and 95,000 skewed the mean away from what would be a more appropriate center value. Another example is the software developer Bill Gates, founder of Microsoft. He has a very high annual income, estimated at more than $1 billion. If he was to walk into a room and you were to survey annual income, you would find that Bill Gates would skew the average for the group of individuals assessed in that room. And so in this example, the average income of this group of people is $100 million per year. And that's not quite representative of the annual incomes of many of the people in the sample, which is more in the range of $30,000 to $65,000. And so when Bill Gates enters the room, he is an outlier, a statistical outlier. He has an exceptionally high income that can skew the average. When the mean is not the best way to assess the center value within a distribution of values, there are 2 other options you can use. The median is the middle value. It's the point in a distribution that divides the values in half. It's the 50th percentile, and that means that 50% of values in that distribution fall above that value and 50% fall below that value. To find out the median, you simply order values from high to low, and you find the center position by adding the total number of values plus 1 and divide that number by 2. That tells you which position to look at, and you identify the value of that position. Now let's go back to the cups of coffee example. So we ordered the cups of coffee values from high to low. You can see they range from 0 to 8. Now there are 7 values, so we add 1 and divide that number, which is 8, by 2. And that tells us to look at the 4th value. And the 4th value is 2, so the median of cups of coffee variable is 2. The mode is the most frequent value in a distribution. It is the value that occurs the greatest number of times within your set of observations. In the cups of coffee data set, the mode is 2 because there were 3 people, persons 1, 6, and 7, who drank 2 cups of coffee per day. How do these mean, median, and mode values compare? What's kind of interesting, the mode and the median are identical, they're both 2. The mean is slightly higher, and the mean is slightly higher likely because of person 5, who is somewhat of an outlier in our sample. Finally, statisticians often look at the range of values as well. The range is the difference between the maximum and the minimum values, and this can help you get a sense of the distribution of values that you observe for various. In our cups of coffee example, range is the difference between the highest and the lowest value. In this case, the range is 8. So going back, I'd like to walk you through a simple statistical analysis that I conducted in using R, which is a free software environment for statistical analysis and graphics. I loaded into memory the data from a midterm exam that I gave a few semesters ago. There are 2 columns in this data set. The left-hand column is MT grade, and MT grade is the total number of points of the exam. So this exam had a total possible number of points of 500. That is the highest number of points that a student could have obtained on this exam. And I transformed the raw number of points into a percentage. So the percent grade on the right-hand column indicates the percent, so it ranges from 0 to 100. So how do we make sense of these data? If we do a simple summary of the percent grade variable, we can see what the measures of central tendency are for the grades on this midterm. For instance, the average, the mean grade on this midterm exam was 73.3. That is, the average score on this midterm was a 73, about a C. The median was 76, and that means that 50% of students scored above 76 and 50% of students scored below 76. And looking below, if we do a frequency distribution of the percent values, we find that the mode, the most frequent occurring value within the distribution of grades, was 76. That there were 4 students who scored a 76 on this midterm. Another way to look at data descriptively is with a histogram. A histogram is a visual representation of a frequency distribution, and it shows us how students stacked up on different percent scores. So this suggests that most students scored between a 50 and a 90, and fewer students scored less than 50 or greater than 90. And this is a somewhat normal looking distribution.